Word problems. Fun. The essential question for today is how can I model and analyze real-world problems using linear equations? So for all of you sitting there at home thinking, when am I ever going to use this stuff in real life? Here's where you can. And I know some of these problems seem a little silly, like, am I actually going to make a graph to do this? But knowing how real-world problems can change and how different payment plans can affect how much you pay for something, and analyzing which plan is going to get you the best value and by how much, these are very important skills that you need for the real world. So I have a nice little green bar down here today. I've been enjoying picking out my different colors, and the reason I have a green bar is because we're going to turn to this problem. It's about a garden, and you may recognize this problem because it was one on the last test. It was a very fun problem that not many people got right, but for those who did, you should be real familiar with it and know how it works and what's going on here. So let me just remind you of it. I'll read it real quick. And again, I'm going to go really quick. It might do to pause your video so you can just read it and understand it a bit. I know some of you like to rush through these videos as fast as you can. Remember, your goal isn't to get the notes done so you can get the 1 point. It's to understand this stuff. So just slow down, pause the video, make sure you understand what this problem is. So I'll read it. The membership fee for joining a gardening association is $24 per year. A local garden charges members of the association $3 for admission to the garden. Non-members of the association are charged $6. And we're actually going to take off this last sentence. It doesn't really matter for us today based on what we're going to be doing. So here's the deal. We have this garden, and you can become a member, and you have to pay $24. Members get in for less money. Non-members, they never had to pay this $24, but non-members have to pay $6 to get in, so they're paying more per time. So I need to establish two variables here because I am, I'm going to graph these linear equations. Let's let the y be the total cost of just how much you pay per, for visiting the gardens. And this is obviously going to depend on our other variable x, which is how many times you visit. Now, members, their total cost, their y, they have to pay this $24 right away, but then every time they visit, they only pay $3. So I have 3x, $3 per time, plus that $24 initial fee. Non-members are going to pay just $6 per time. They don't pay an initial fee. And I'm actually going to do the non-members in blue, but I'll change my color once we get there. I want to determine which one of these plans is better and when. Because think about this with me. If you're a non-member, you don't have to pay this initial $24, right? That's convenient. But you are paying more per garden visit. So this plan is going to be better sometimes. The members plan is going to be better sometimes. Let's see which plan is better and when. So let's label our axis y and x. I'm going to graph each of these equations. Now, this is in slope-intercept form. 24 is my y-intercept and 3 is my slope. But since I'm starting at 24 and then going up 3 and over 1, I should probably scale my axes a little bit different. In fact, let's scale them by 6s. So 6, 12, 18, 24, 30, 36, 42, and so on. X, I'll just scale 1, 2, 3, 4, 5, and so on. So keep in mind, on the x-axis, this is going to be how many times we're visiting, and the y-axis is going to be the cost. And let's graph these equations. The members equation, the y-intercept is 24, so I'm paying 24. And I'm going up 3 and over 1. Keep in mind that since I'm scaling by 6, whenever I go up 3, it's kind of like going up half a grid line. So up 3 over 1, up 3 over 1. Here's my line. And remember, this graph could go on forever depending on how many times I visit. Now this non-members of equation, let's do this in blue. For the non-members equation, we notice that I start off with a y-intercept of 0. There is no y-intercept there because they're not paying that initial fee. So I'm going to start out at 0. But every time they are paying for the garden, they're going up 6 over 1 because they're paying they're paying $6 rather than $3. So up 6 over 1, up 6 over 1, up 6 over 1, and so on. And if I had drawn my red line just a little bit better, you would notice that these points intersect right here. Here's where they switch. So actually, let me go back and draw my red line just a little bit better. So what do we notice about these two lines? We notice that the red line starts out higher, right? Because that means members are paying more to start. But notice their line is going up by less because each time they enter the garden, they're only paying $3. The blue line starts out less because they're not paying an initial fee, but their line goes up by more. So when does the blue line become more costly? Well, that would be after, 8 times? So at 8 times, the plans are equal at $48. So at each plan, after 8 times visiting the garden, we have the members and the non-members as having paid equal amounts. Before then, look, the red people, the members, are paying more, and the blue people, the non-members, are paying less. But after 8, now all of a sudden, the blue people, the non-members, are paying more, and the red people, the members, are paying less. So which one is better and when? Well, before 8 times, wouldn't you say it's the non-members? And the reason it's better at the beginning is because they do not have to pay as big a fee. They don't pay this initial fee. But after 8 times, whoa, what's going on? After 8 times, after 8 times for the last time, we see that members are better because even though members pay the initial fee, they get to pay less per garden. It just takes a while for that benefit to kick in since they paid more in the first place with the initial fee. All right, let's move on to another problem. You spend $60 for hockey tickets. You must also pay $4 per hour for parking. So we're going to call this the old equation. Let's represent this problem right now. Y is going to equal, again, the cost. And in this case, we have X representing the per hour parking. So let's think about how that would look. The Y, my total cost, I've paid $60 for the hockey tickets, and then I'm also paying $4 per hour for X. So there's my first equation. Later, the hockey team decides to raise the price of parking to $6 per hour. So I have Y equals 60 plus, now it's no longer just 4X, it's 6X, okay? And I want to know how much do you save on the old payment plan when you've parked for 5 hours. So in other words, I want to compare these two lines. They both have the same starting value. I'll count by tens this time, 10, 20, 30. Here's my cost, 50, 60, 70, 80, 90, 100. So for the old plan, the cost is, again, starting at 60, and it's going per hour. Down here are the hours. It's going up 6 over 1, up 6 over 1, up 6 over 1, something like this. So that's going up a certain amount. The old equation, though, doesn't this old equation go up slower? Because I have a lesser slope, and the reason I have a lesser slope is because I'm paying less per hour for parking. So starting at 60, I go up 4 over 1, up 4 over 1, up 4 over 1, up 4 over 1. It's looking something a little more like this. So they both start at the same value because we're paying $60 for tickets in each case, but red is going up less than blue. And what I want to know is how much do you save on the old payment plan when you have parked for 5 hours? Now what I could do is I could look at my graph at 5 hours and I could see, okay, I'm paying this much for the old payment plan and I'm paying this much for the new payment plan, and kind of what's the difference in cost. I don't really know, like my graph is not that accurate though. So let's think about what I could do here. Doesn't this 5 hours represent the x? So if I plug 5 hours in both equations, that should show me the cost of both equations. So let's look at the old payment plan, the $4 payment plan, and let's see what the cost will be when I plug in 5 for x. Well, 4 times 5 is 20, and 20 plus 60 is 80, so I'm paying $80 under the old payment plan. Under the new payment plan, let me switch to blue. Under the new payment plan, when I am at 5 hours, well, 6 times 5 is 30, and 60 plus 30 is $90. And you can kind of see on the graph, oh yeah, when I'm over at 5 hours, looks like red's up at 80, and it does look like blue is up at $90. So how much do I save? Well, the difference in these is $10. Nice. So modeling these different equations helps me to see the full range of different costs according to how much time I've spent in the parking lot. So summary, in a real-world context, keep in mind, what did slope equal? In this problem, it was how many dollars per hour. That ended up being my slope. In this problem, it was how many dollars for admission per time. So slope always equals the rate of change, and that's something that we've talked about before. The y-intercept, let's think about what that was. Here, when we started at 60, that was the y-intercept, and that was kind of my initial how much I was paying. I paid $60 for the tickets, and then after that, it became more with the parking. In this problem, I started off with 24. That was my membership fee. That was my initial cost. So in a real-world context, the y-intercept is kind of like the starting value or the base cost or the initial fee before I start applying this rate of change. All right, hopefully that helped you understand some real-world context. Sorry for the length of the video, sorry for the boringness of my voice, but hopefully that provided you some insight into how graphing these equations can really help me analyze situations. Au revoir.